Let us start homework 2. The first question is chapter 2 problem 6b. 6b. Use MATLAB and symbolic math toolbox to find the inverse Laplace transform of the following frequency functions. It is a MATLAB question, and in exam he won't ask for MATLAB questions because you need a MATLAB software to do that questions. So leave that question. And next question is ninth one. Write the differential equation for the system shown in figure. Okay, differential equation for the system shown in figure. S power 5 plus 2s power 4 plus 4s cube plus s square plus 4 divided by s power 6 plus 7s power 5 plus 3s power 4 plus 2s cube plus s square plus 5. R of s, the system. This is a system. Now we need differential equation representing this system. So if any system is represented by this, here this R of s and C of s, this is input and this is output. This is a system transfer function. So suppose you have a as simple as that, have a motor. Let us take a motor. Everyone knows motor. For motor you give electrical supply and the shaft will be there and it rotates. So you see only input supply, input voltage you apply, and you see only the this is the input and this is the output. You see shaft and you don't know the anything inside of it, how it goes, how it does, it works, and how it performs the operations, all those things. So same assume here. Here V of s is input and the here output means shaft speed. Speed means n of s. Let's say n, speed is n. N is the output, and this system, the motor, is called system. So in mathematical manner, you suppose if somebody wants to analyze this motor, he needs the motor transfer function like this, and input we know and output we know. So this is the background about system. This is background about the system and input and output. And if it is if the system is represented like this, so we can write as C of s. This is output, input R of s, input equal to, and C of s by R of s is exact system function, s power 5 to s power 4 4s cube plus s square plus 4 divided by s power 6 plus 7s power 5 plus 3s power 4 plus 2s cube plus s square plus 5. This is output and this is input. So now what they have asked, write the differential equation for the system. The question exactly, write the differential equation of the system. So you know the differential equation, usually the differential equation, general differential equations, like how it will be, dy by dt equal to x of t. or this is the first order. Dy by dt square plus something some 5 dy by dt some x of t. This is the second order. Why I'm saying this second order? Because here 2, here 1. This is only one time differentiation. This is 2 times differentiation. So this is second order. So what you can observe is here it has two functions y and x. You can write y of t simply dy of t equal to x of t. It has two functions y and x. Let us say this is input and this is output. Therefore there is a relation between output and input in terms of differentials, like d square y of t by dt square. In terms of differentials of one time differentiation of y and second time differentiation of y, like this. So this is called differential equation. Writing input, exact what it says is writing input and output in terms of writing input and output involving differentiations, like differential operators, d square or d cube. Writing input and output relation which involves differential operators. Differential operators are d by dt, d square by dt, like this, d cube by dt, d power 4 by dt. So suppose our function, we want to write this function in differential form. Now here s means frequency. It means frequency. S means frequency. T means time. So this transfer function is in frequency domain. Now in order to write differential equation, we see here it is in general differential form in terms of time. So we need to convert into time domain. This convert into time domain. How to convert it? Again write the differential equation here. Now we have C of s by R of s equals to s power 5 to s power 4, something like this. Same way here in the denominators, s power 6, 7s power 5 and 3s power 4, like this. So now we know we can multiply these two together and we can multiply these two together. So now s power 6 plus 7s power 5 plus 3s power 4 plus 2s cube plus s square plus 5 into C of s equals to R of s into s power 5 plus 2s power 4 plus 4s cube plus s square plus 4. Now now you can see we are going to approach the form. So we should write this equation in terms of dc something d square something which involves here by dt equals to dr by dt. This is the form we need to get. Okay, how we can get that form? Let's see. So this is the S domain. We need T domain equation. For C of T, if you convert into, this is time domain and this is frequency domain, it becomes C of S. And these are Laplace transform properties. You can find these, what I am about to write, you can find this on Laplace transform table. Suppose you have differential, one time differential of input, which gives S into C of S. And if you differentiate one more time, which will give us, and if you dq C of T one more time, we get S cube of C of S. And if you do one more time, it's power 4 C of S. So C of T converting time domain to frequency domain or frequency domain to time domain. That's why I have shown the double-sided arrows. You can convert from this to this, and you can from this to this. C of T becomes C of S. Again, C of S becomes C of T. Suppose if you have S into C of S, it becomes d by dt of C of T. And suppose if you want to convert from time domain to frequency domain, if it is d by dt of C of T, it will become S into C of S. Same way for S square, this thing, same way. So now we have a function here. This is our function. Now I'm going to write everything here. S power 6 C of S plus 7 S power 5 C of S plus 3 S power 4 C of S plus 2 S cube C of S plus S square C of S plus 5 C of S equals to S power 5 R of S plus 2s power 4 R of S 4s cube R of S plus S square R of S plus 4 R of S. Now the next step is, so we know for S power 6 C of S, here d power 5 d C of T is S power 5 C of S. Same way, d power 6 by dt power 6 C of T is S power 6 C of S. So now it is d power 6 by dt power 6 C of T. Same way, put 7 here and S power 5 into C of S. So d power 5 by dt power 5 C of T 3 times d power 4 by dt power 4 C of T 2 d cube by dt cube C of T plus d square by dt square times of C of T plus 5 times of C of T. Yes, there is no S term, so C of T plus 5 times of C of T equals to d power 5 by dt power 5 R of t. And one more thing is it is in capital letters, and it should be in small letters, so that's why I used 2 d power 4 by dt power 4 r of t 4 d cube by dt cube r of t plus d square by dt square r of t plus last one is 4 into r of t. So this is the differential form of a given question. Differential form of given question. Now let's move on to the other question. Next question is 14b. Okay, 14b. For each of the circuits, find transfer function g of s by v of s. And one more point I want to mention here is this is called if you write in a frequency domain, output by input is a transfer function. This is a transfer function of this system. This is transfer function. Okay, transfer function gives us a relation between output to input. Transfer function is relation between, otherwise you can write ratio of output to input in frequency domain is called transfer function. So for B, the circuit is 1 ohm, and it is 1 ohm and 2 Henry and plus minus, this is Vi of t, 1 farads. This is a point where they are taking output. First of all, we need to convert this circuit into S domain, because the transfer function is V of S by Vi of S. So we need to convert this into S domain, this and everything. The total circuit should be in S domain. 1 minute. Now, so for resistance, it is same in time domain and frequency domain. For inductor is represented by L, inductor, and its symbol is like this. This is inductor, and it is represented by L, and it looks like this. For this, the frequency domain is SL, and after that capacitor. It is C. It is represented by C, and the frequency domain is 1 by AC. Now, let's continue. So our circuit is 1, so 1 will stay same 1, and this also stays same. It will become SL. SL means S into L is 2, so it is 2S. And one more thing is here, this is here Vi of S. Vi of t becomes Vi of S, and V naught of t becomes V naught of S, and capacitor 1 by SC. 1 by S, C value is 1, so 1 by S. Here also SL means S times of L. L is 2 here in the above circuit. L is 2. L value is 2 here. So we know, first of all, we need to convert this circuit into S domain. The transfer function means V naught of S by Vi of S. That's why we need the entire circuit in S domain. So for time domain to S domain conversion, if it is a resistance, it stays same. If it is an inductor means it look like this, and it has shown by the value L. It becomes SL, S times of L. Suppose inductor is 2 Henry, S into 2, it will becomes 2S. Inductor is measured in Henries, resistance is measured in ohms. Now other thing is capacitor. Only these three elements should be there, and there is a capacitance C. So capacitance, this name is capacitor, and it has it represented by the symbol C, or you can see this can be also a capacitor. It should be one line, and the second one is curved line. It's curve. They can represent like this, or they can represent the parallel lines exactly same length. If this is one thing and this is other thing. If it is like this, one is a height, one having the more height other than that, then it is a DC supply. If both are same, then it is a capacitor. DC supply measures in volts, and capacitor measures in farads, and it has a unit of farads. The conversion is 1 by SC. Suppose the C is 1 farad, it will become 1 by C is 1 farad, so it is 1 by S. Now we have converted the total circuit into S domain. Now we should do circuit analysis. This is the ground. We should do circuit analysis to find the relation between V naught of S2. We need a relation, some constant, into Vi of S. We need to derive this. For this, how we should do? This is a joint of three nodes. This, and this are connected together like a one ohm, one end, and I brought another one and its end, and this is the one inductor, this end. I have tied these three together, and I have given supply to this, and I connected and I put a capacitor here. Suppose you have a, you can say, let us say you have a computer with you, and you have a plug box, that means extension box. There is a wall, there is a socket. You take power supply from that socket, and you have given to extension box. There is there are more pins. You can use many load like this, and after that you have used some load. You can say, what you can say, suppose if you put some load, yeah, suppose if you put your mobile phone charger, you put mobile phone charger here, and after that you put something like other. Suppose if you put your trimmer, and you put here your some loads, so that means you are just you're taking supply. After that out of that it has given to some other points. Out of that you took parallel loads from this, like you can understand. Suppose in your house, in a wall, there is a power socket. You take power supply from that, you have given to extension box. There are different power supplies. You can take like this, you can take like this, you can connect to other thing, you can connect to other thing. This is all a circuit analysis. So the power supply, how we represent power supply, this is the power supply, and after that this is a point where you are taking many loads. So at this point you are taking many loads. Loads can be represented by R or L or C. Load can be represented as any terms. So this is a simple circuit. Supply voltage and the loads, load 1, load 2 and load 3. This is the realistic example of the circuit to understand it better. So now let's proceed to our circuit. So 1 and SL 2S, and this is 1 by S. This is V naught of S. This is VI of S. So this is a junction point of three things. So I represent this as V of S. Vx of S. Okay. Now so I want to draw in a more simplistic manner. One you can put it as 1, and this is Vi of S, and 1, and it is 2S, and it is 1 by S. This node, this junction point, we represent as the voltage available at junction point. We represented with some point. Now KCL, Kirchhoff's current law. Current law means, suppose you have some elements coming like this. You put a junction here. You suppose you have connected at this point the current I1 and I2 and I3 and I4. At this point, current incoming equals to current outgoing. Current incoming to node equals to current outgoing. So therefore current incoming at this junction, current incoming, current coming into this node. So I1 plus I2 plus I3 equals to current outgoing. This current is going I4. This is a KCL. Now we are going to use that KCL here. So let's make directions like this. So from this load, current is outgoing. You can represent anything, you can represent like a incoming also. So suppose if you represent all in the same direction, it is easier. So current is outgoing here, current is outgoing here, current is outgoing here. Now apply KCL. And one more thing is, if two elements, suppose this is a load 1 and load 2 in series, this is called series connection. One end connected to other one's beginning, and this is a parallel connection. If the elements, let us say some Z1, impedance 1 and impedance 2, impedance represented by the Z. Impedance means R is resistance and L is inductance and C is capacitance. If you combine these two, suppose there are circuits having both inductance and capacitance, all those things, it is represented by impedance simply. Z1, Z2, Z1, Z2. If it is in series, this is parallel, this is series. If they are in series, you can add both together, Z1 plus Z2. If they are in parallel, you can represent as a single in such a way that Z is Z1 Z2 by Z1 plus Z2. Here you can represent Z as Z in such a way that Z1 plus Z2. In case of parallel connection, you can represent such a way that Z1 by Z1 Z2 into Z1 plus Z2. Okay. Now let's get back to the original circuit. Here one more thing is, suppose we have Ohm's law. Ohm's law tells us V, voltage equal to current times of resistance or current times of impedance. Okay, therefore current equals to voltage by Z or voltage by R. Okay, impedance simply. Current equals to voltage by impedance. So suppose, what is this voltage? And so you have some resistance, some S here, and you have given supply V. What is the current? So you can say current is voltage by S in S domain, I of S. So here the voltage is voltage across this element across voltage, the voltage given to this element is V. Okay, now same way this current, let us take this is I1, this is I2 and this is I3. This current I1 is voltage across this by 1. Okay, so therefore I1 is voltage across that is Vx of S minus Vi of S by 1, because it has, suppose current is going like this, it has V1 of S and V2 of S, and this is 1 ohm 1. The voltage across this is V1 of S minus V2 of S, because both ends having voltage, we need to take subtraction. Okay, and now I2 is, so here only having one source, there is no other voltage source here, so across voltage is Vx of S, so Vx of S by 1. Next I3 is Vx of S by So if these two are in series, you need to add those two. 2s plus 1 by s. So therefore I3 of s becomes Vx of s by, take a s as common, 2s square plus 1. So it will come up s by I3 of s, Vx of s. So now combine these three. So we know KCL, all are outgoing currents equals to incoming currents. No, there are no incoming currents, so it is 0. So I1 is Vx minus Vi plus I2 is Vx plus, and I3 is s by 2s square plus 1 equals to 0. There is a Vx. Take Vx as common. 1 plus 1 plus s by 2s square plus 1 equals to Vi. Now 1 plus 1, 2 plus s by 2s square plus 1 into Vi. Now let's see. 2 by s by 2s square plus 1. How it becomes? So this is all simple mathematics. You take as a common here. So now you should multiply with that element and s. Now just go inside. 4s square plus 2 plus s by 2s square plus 1. Therefore now substitute this Vs 4s square plus s plus 2 divided by. Therefore Vx equals to, you can move s to s square plus 1 by 4s square plus s plus 2 times Vi. This is the first one. And after that, suppose you have a voltage V1, you have impedance Z1, this is ground, you have impedance Z2, these two are in series, and voltage, this is voltage V. Voltage across Z1 is V1 and voltage across Z2 is V2. The total voltage is V. Total voltage is V, but voltage across Z1 is V1, voltage across Z2 is V2. Now we know the current I. V is equal to IR, the same formula. So voltage V equal to current I into resistor Z or R, both the same. So if they are in series, you need to add both I1 plus I2. Therefore current equals to the circuit current. The current flowing in the circuit is V by Z1 plus Z2. So we got current. Suppose we want V1 comma V2. How you find? V1 equals to, from the Ohm's law, current I1 into Z1. The same way V2 equals to I2 into Z2. V1 equal to, this is a series circuit, the current I1 equals to I2 equal to I. The same current will flow all over this path. So this is I Z1, same way V equal to I Z2. And V1 is, we know what is I? V by Z1 plus Z2 into Z1. Same way V2 equals to I V by Z1 plus Z2 into Z2. Now you can write as Z1 by Z1 plus Z2 into V, Z2 by Z1 plus Z2 into V2. So in order to find, you have two circuits, Z1 plus minus V1 to Z2 and V2. You have supply voltage V. So voltage across V1 and voltage across V2 you can find directly without using Ohm's law. How? This is called voltage division. So V1 equals to voltage across one load equals to total voltage multiplies with total voltage V multiplies with its impedance is Z1, and total impedance is Z1 plus Z2. So this is what exactly we got, V1 by same way. Suppose you need voltage V2, total voltage multiplies with its impedance Z2 by total impedance Z1 plus Z2. But this is valid for only series circuits. These are in series, that's why we did this. So now, so going back to our circuit, we have Vx of s, and after that we have 2s, after that we have 1 by s, and I just take one branch of the circuit. You have one, there is a circuit this side, but I just took this to get this V naught of s. So apply voltage division. V naught of s equals to total voltage Vx of s into multiplies with its impedance 1 by s by total impedance 2s plus 1 by s. So Vx of s multiplies with 1 by s by 2s square plus 1 by s. Now Vx of s into this s and this s cancels each other, 1 by 2s square plus 1 for V naught of s. This is equation number 2. So, and what is the equation 1? Equation 1 is Vx of s is equal to two s square plus 1 by then it is correct, 2s square plus 1 4s square plus 2. Yes. Now this is the first equation. Now put equation 1 in equation 2. So now V naught of x equals to Vx of s is 2s square plus 1 by 4s square plus s plus 2 into Vi of s multiplies with 1 by 2s square plus 1. So you can cancel this. So now we left with V naught of s by V naught of s is equal to Vi of s by 4s square plus s plus 2. Now move this side. V naught of s by Vi of s is 1 divided by 4s square plus s plus 2. This is what they have asked. It's a transfer what is the exact question? Find the transfer function. So therefore this is a g of s equals to v naught of s by v of s. We get 1 by 4s square plus s plus 2. This is the circuit they have asked. 1 ohm, 1 ohm, 2 Henry, 1 farad. First we have converted into S domain. So for inductor it is SL, for the capacitor it is 1 by SC. So I have converted this into S domain circuit, Vi of s and V naught of s and all elements in S domain. After that I have explained about KVL, how KVL can be implemented, and after that we have took the KVL, and after that the currents I1, I2, I3, I1 and I2 and I3, and all currents are outgoing, so we added all those currents, and after that we took Vxs common here, and we shift the Vi right side, and we have established a relation between Vx and Vi. After that we apply voltage division. How voltage division exists, I have shown. And after that we applied a voltage division to our circuit, and we got a relation between Vx and V0, and I named as equation 2. I just bring the equation 1 and put in the equation 2, and we got a relation between V0 of x and Vi of x, that is 1 over s square plus s plus 2. This is the second question, and later we will see the other questions.